Hello, Math Wizards! Welcome to a new lesson episode of Just Math PH. So for today's lesson, we will be learning more about quadratic equation. We will also be identifying quadratic term, linear term, and constant term. And also, we will be transforming quadratic equation into the standard form. So as a review, quadratic equations are equations of degree 2. It means that the highest exponent of the unknown variable in our equation is 2. Now we have here the standard quadratic equation, which is ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. A, B, and C here are given numbers. Now this leaves us that x is our unknown variable. Now notice that the highest exponent of the variable x is 2. That's why this is called the standard quadratic equation or the quadratic equation. For example, 2x squared plus 3x plus 1 equals 0. We can identify the values of a, b, and c here. Now a is equal to 2 and b is equal to 3 while c is equal to 1. So 2x squared plus 3x plus 1 equals 0 is an example of a quadratic equation. Now let's understand deeper the terms of the quadratic equation. So we have here ax squared, and we call that term to be the quadratic term. Now we can remember the quadratic term as the term with degree 2, or it has an exponent 2. Well, the bx is what we call the linear term. We can remember this term by remembering the exponent of x, which is 1, or we call it the term with degree 1, since x here has an invisible exponent of 1. Again, this term is called the linear term. Well, c is what we call the constant term. Now, this term can easily be remembered with the term with no variable. Now, let's practice identifying the quadratic term, the linear term, and the constant term of the quadratic equation. For example, 2x squared plus 3x plus 1 equals 0. So again, the quadratic term is a term with the exponent 2. So our quadratic term is 2x squared, while our linear term is 3x, and our constant term, or the term that has no variable in it, is 1. Now, we can also identify the values of a, b, and c. So remember that a can be found in the quadratic term. So this is the numerical coefficient or the number part of our quadratic term. So a is equal to 2. Well, the linear term, we can find here the b. This is the number part of our 3x, and b is equal to 3, while c is equal to positive 1. Sometimes we have quadratic equations that has no constant in it. For example, ax squared plus bx equals 0. So obviously, there is no constant here. But this is still an example of a quadratic equation because it has an exponent of 2 for the unknown variable x. Now, ax squared is still the quadratic term and bx is still the linear term. Now, let's have an example and identify the terms here. For example, x squared plus 5x equals 0. So our quadratic term is obviously the x squared, while the linear term is the 5x. Now we can identify the value of a in the quadratic term and the value of b in the linear term. So a is equal to 1 since there is an invisible 1 here, and b is equal to 5. Now, how do we answer the value of c? So even though there is no constant term here, we can understand that c is equal to 0. Now, sometimes quadratic equation can have no linear term. So, for example, ax squared plus c is equal to 0. So, this is still a quadratic equation because, again, we still have the quadratic term. So, ax squared is the quadratic term, and c is obviously our constant term. Now, let's identify the constant term and the quadratic term of this example, 2x squared minus 8 equals 0. So 2x squared is the quadratic term, and negative 8, again, negative 8 is the constant term. So do not forget to include the signs of the terms when mentioning them. Now our a is equal to positive 2, and our b is 0. So since there is no linear term, it is understood that the value of b here is 0. And the constant value for c, or c, is equal to negative 8. So how about if the quadratic term is missing? So we have your bx plus c equals 0. So bx is the linear term, and c is a constant term. So we don't have the quadratic term here. For example, 5x plus 10 equals 0. But the very important question here, is this an example of quadratic equation? The answer is no. This is not a quadratic equation since the quadratic term is missing. So mawala na lahat sa linear term or si constant, but never the quadratic term. Now 5x plus 10 equals 0 is an example of a linear equation, but not a quadratic equation. Now, there are equations or quadratic equations that is not written in the standard form. So we have to transform them into the standard form of the quadratic equation. But how do this standard quadratic equation must look like? So first, the right-hand side of the equation must be equal to 0. It means that if there are terms on the right side, we must transfer everything to the left side of the equation. So since there's nothing left in the right side, we must put, again, remember to put equals 0 since nothing is left there. Next is the left-hand side of the equation must be arranged in descending order, which the quadratic term must come first, followed by the linear term, then followed by the constant term. Lastly, I encourage my students to always write the quadratic term in the positive form. So to do this, we have to multiply both sides of the equation by negative 1 if ever the quadratic term is negative. We will transform this quadratic equation into the standard form and then identify the values of a, b, and c. So to transform this, we have to distribute 2x inside the parentheses. So first, 2x times x, that is 2x squared, and 2x times negative 4, that is negative 8x. Copy positive 12. Next, we will transpose 12 to the left side of our equation. 2x squared minus 8x. Since we will transfer, the positive 12 will become negative 12. Copy equals, then write 0 on the right side of our equation, since nothing is left on the right side. Now this is already in the standard form. Now, since this is in standard form already, we can identify the values of A, B, and C. A can be found in the quadratic term. It is the number part or the numerical coefficient of the quadratic term. So A is equal to 2. Now for B, this is the numerical coefficient of the linear term. So B is equal to negative 8. And for the C, that is the constant negative 12. Common mistakes of my students is they write x for b. So b, usually they write b equals negative 8x. So that is wrong because b is only the number part or the numerical coefficient of the linear term. For our next example, we have 3x squared plus 1 equals 0. Now this is already in the standard form. So we can identify, we have here the quadratic term and the constant term. Notice that we do not have the linear term. However, this is correct because this is already arranged. Now we can identify the A, which is positive 3, and the C, which is positive 1. Since the linear term is not visible here, it means that P is equal to 0. Next example, x minus 3x squared equals 0. So, the left side of our equation, we have here the quadratic term and the linear term. However, this is not arranged. The quadratic term should be placed first and then followed by the linear term. So we can write negative 3x squared, then positive x equals 0. So notice that negative 3, the sign of negative 3 remains the same here because we did not transfer this to the other side. All we did is we arrange it on the same side. So do not change their sign, remain it as it is. Now, I always encourage my students to make the quadratic term into a positive sign. So for us to do this, we have to multiply both sides of our equation by negative 1. So multiplying it, we have negative 1 times negative 3x squared. We got positive 3x squared. And negative 1 times positive x, that is negative x, equals 0 times negative 1, that is 0. This is already arranged in the standard form. Notice that we do not have the constant term. So our c here will obviously be 0. But we have the value for our A, which is positive 3, and B, which is negative 1. Since there is an invisible 1 here, and that is B equals negative 1, and C is equal to 0. We have here the next example, the product of the binomial x minus 1 and x minus 8 is equal to negative 9. We have to distribute x here and negative 1 here. So to do that, x times x is equal to x squared, and x times negative 8, that is negative 8x, and negative 1 times x, we have negative 1x, or you could just write negative x, and negative 1 times negative 8, that is positive 8. Copy equals negative 9. Now we do have similar terms here. Negative 8x and negative 1x. We can combine these terms. That gives us negative 9x. Then we could just simply copy x squared and positive 8. Now we will transfer negative 9 to this side, and that becomes positive 9 equals 0. Positive 8 and positive 9 can be combined, that is 17, positive 17. Then we will just copy negative 9x and x squared equals 0. So we have x squared minus 9x plus 17 equals 0. This is the standard form, and we can identify the a. So there's an invisible 1 here. A is 1, b is negative 9, and c is positive 17. Well, we have the product of the binomial x plus 3 times x minus 3 equals x times the binomial 4x plus 5. So we will distribute these terms here to this binomial. We have x times x, we have x squared, and x times negative 3, that is negative 3x, positive 3 times x, that is positive 3x, and positive 3 times negative 3, that is negative 9, equals x times 4x, that is 4x squared, x times positive 5, that is positive 5x. On the left side, we notice that we have similar terms. We can combine them. Notice that negative 3 plus 3, or negative 3x plus 3x, is 0. So we could just cancel that out and write x squared minus 9, copy minus 9, equals 4x squared plus 5x. We will transfer these two terms to this side. We will place 4x squared beside x squared. So we have x squared, transfer 4x squared, we have negative 4x squared. Then we will transfer positive 5x, that becomes negative 5x. Then copy negative 9 equals 0, since nothing is left on the right side. We can combine this. We have negative 3x squared, because 1 minus 4 is negative 3, minus 5x minus 9 equals 0. Now, since our a is negative, we can multiply both sides of our equation by negative 1. So we have 3x squared plus 5x plus 9 equals 0. This gives us our a is 3, our b is 5, and our c is positive 9. This is our standard quadratic equation.